I'm getting ready to measure the noise figure of the LNA. So I have an 18-volt power supply, and that drives this noise source. It requires 15 to 30 volts. And this is the output right here at this SMA connector, which I can connect directly to low noise amplifiers, transverters, what have you. So how it works is, it is a 5 dB excess noise source, which means it's adding 3.16 times 290 Kelvin, 5 dB, to the 290. So the total noise output is 1207 degrees Kelvin. When you turn the device off by disconnecting the 18-volt power supply, it drops to the thermal noise of this attenuator to 290. So what you actually measure then on the output of your device under test using a noise meter, which is this great instrument I have, you will measure the difference between 1207 plus the device under test and 290 plus the device under test. That Y factor is looked up on a chart. So for example, if I measure 5.6 as a Y factor in dB, so 5.2, 5.4, 5.6, that would be a noise figure of 0.3 dB of your device under test. I'm going to practice measuring the noise figure of this transverter. So I have the excess noise source attached to the DEME transverter, and right now it's turned off. There's no 18 volts supplied to the DC input on the noise source, and the transverter, of course, is feeding the 144 transverter to provide a 28 megahertz output, which I'm measuring on the noise meter, and I've just calibrated this for 0 dB reference. Okay, so this is my reference noise level. And the Anand can also process that 28 megahertz signal, and I've got it calibrated at minus 174 dBm per hertz. This is just an arbitrary level, but it just shows a reference noise level. I'm now going to connect 18-volt power supply. The noise has gone up 4.8 dB. And we see 169 from 174. So that looks exactly the same. And if we look at the chart, 4.8 is just under 2 dB noise figure, 1.9. And that is the spec of the DEME transverter, 1.9 dB noise figure. It works. So I'm able to measure noise figure at microwave frequencies. I'm now measuring the noise figure of the second LNA. This is the primary LNA, which is destroyed. Arsenide transistor, an HJFET will have to be replaced. But this is the second LNA. There's a filter between these two to get rid of wideband Wi-Fi noise. So let's see what's going on here with the noise source. So it's a 5 dB excess noise source. I have set the reference level to 0 dB. And I've just got a reference level on the Anand as well, which is monitoring 28 megahertz, minus 175 on the relative scale. So let's turn on the power supply for the noise source. Stand by. Okay, it's connected. And we have an increase of 5 dB. 5 dB increase in noise. And of course you can see that on the Anand as well, minus 175 plus 5 is minus 170. So there's the 5 dB increase. So that's our Y factor. So we look at 5 dB on this chart. And we're between the blue and the red line because the actual noise source has been calibrated at 4.8 for this particular serial number unit at 2304. So if you look at 5 dB, and between the red and the blue lines, it's about 1.3, 1.4 dB. That is the noise figure specification for this Down East Microwave Mimic second LNA, 1.3 dB. So we have confirmed that it's working and the noise figure is reasonable.